Hi, this is DC here. Welcome to this new video on the Omnikey 5422 reader writer. This is a product from HRD Global. I bought this device a week ago and I thought I could make a few videos that could help you as well. Now, some of the important features of this product is this is a successor of Omnikey 5421. I made few videos using 5421 on how to use contact and contactless cards as well. Please, if you're interested to know, please take a look at those videos. If you visit the manufacturer website for 5421, you can see this product has been discontinued and it is there's a replacement, that's Omnikey 5422. And if you go to the 5422 products, you can see there are lots of information here. There's a brochure. It speaks about all the standards and taxes supports, plus also there is more information about the developer guide as well. If you're a developer, I would advise you to download the developer's guide from the website. Like 5421, this is also a dual interface device, supports both contactless and the contact cards. It supports the three standards: the ISO 1443 type A, type B, and ISO 15693 tags. And the reason for me to buy this device is when I was playing with the ISO 15693 tags, especially using like a iCode, SLIX 1 and 2 tags, I was not able to send some of the proprietary NXP commands directly to the tag. So I was talking to the support, and the support advised me to go with the new version. It's a 5422. And they say this has got a better firmware which is more flexible and which allows us to use some of this or send some of the proprietary commands directly to the tag. Now I'm going to show you how to use the SLE5442 or SLE5542 contact cards. And if you have already got 5421, you might have noticed sometime what I have seen is somehow the SLE4442 did not work for me with the 5421. Now I'm not very sure the reason for that. However, I'm happy that these contact cards work very nicely. If you're a developer, you'll be really happy to see how easy now it is to read and write for these devices. As you can see here, I've got my Omnikey 5422 device which I bought last week, and you can buy this from many places, from Amazon or eBay or some distributor's website. Now these devices, you don't have to install any drivers, so that's the good thing about devices these days. Now you can see I have opened my device manager. I'm working on a Windows 10, and as soon as you connect, you should see these two entries. Now there are two entries. The reason could be one is for contact, other maybe for the contactless. And somehow I did not see a nice name like a Omnikey 5422 devices here. So it doesn't matter, it works. Okay, now you can, this is the software I have been using to demonstrate how to read and write with the contact memory cards. And the Omnikey 5422 versions available in version 1.6. If you already have the software, you get an automated updates. If you don't have the software, you still get a lot of information from this video. So the first thing we do is just get the readers. So click on get readers. Now you can see there are two readers, interfaces available. One is the top one is the contact, the bottom one is the contactless. That's shown here with the CL. Choose the contact, and I'm going to click on connect. Before I do that, I'm going to insert a brand new SLE5442 contact memory card. Now sometimes it will take some time before the card, before you're actually able to connect. Now when you click the connect, what the software has done, it has retrieved the ATR from the card, and it knows based on ATR this is SLE5442. Now there are many options here, but none of these are ready yet, so you can use only SLE5442. So this is the command section, which if you're using the software, this screen shows all the commands from the API documentation you have to use to read and write these type of tags. The first thing is you can get an ATR. This is a standard the Windows Smart Card API, which is the function used in the SCART state, and this is the ATR of this tag. By hitting go, so we are trying to read. You can see that there's a lot of flashing going on here. Now SLE5442 has got 256 bytes of memory. The entire data has been read into the software. If you look at the various commands that are used, these are the commands you have to send, and these commands are very well explained in the developer's guide documentation of 5422. So if you have seen my videos on using ACR 39U from a company called ACS, there is only one single command that reads the entire 256 bytes, but here you have to send, or there is a command to read just 1 byte of data. And if you can see here, there are 256 commands sent one after another to read a byte every time. So just if you want to go through this commands, probably I will spend one more video about these commands. Let's quickly go through what you can do here. I'm going to read that SLE5442 has got the first 32 bytes of data can be protected. So the card has a 32-bit additional the protection memory. So when I hit the read button, so what has happened is there is a command called read protection memory, which is sent to the device, and this is the command structure, and this is what you got as a response. And you can see here now the 9D, you'll see this in all the responses. 9D indicates a success response, followed by, this is the length of the response, 04 bytes, followed by the actual response. And these are the standard ISO 7813 type of responses, the status code 9000. Now you should always look for 9D and followed by the length. Now once the software reads these 4 bytes, it just fills up some color here just to show these bytes have been locked when you buy a new SLE tag, and these memories cannot be, these locks cannot be removed, so you cannot modify this. Now you know that from my previous videos, SLE5442, the write operation is password protected. You must authenticate before doing any write operation. So all new tags, they come with the factory default password, is all FFs. Now I'm going to authenticate. Now there's one interesting thing it's happening in this authenticate command. So if you're a developer, you will appreciate that these commands that are used matches the documentation of SLE5442. Now what has gone here is, see, the authentication is successful, and it says I have got the error counter is 7. So this is as I mentioned in other videos, I've got 3 tries. Now what the authentication command has done is, this is exactly what the documentation says. If you have a document on SLE5542. So it's the right time you compare these commands with the documents. This is the document about SLE5542. Here it's explained how you can authenticate, and this is the sequence we have been following. You have to update the security memory, compare, then again update the memory back to FFs, and you can read it. Now it's exactly what has gone here as well. First, what the software has done is it has the error counter, it has set the error counter, or it has reset one of the bit of error counter. You know, my other videos which I explained everything in detail, we have got 3 tries. You have to first make one of the bit as 0, so that gives you number 6. That's exactly what you see here. Then you have to compare, send the verify security memory command 3 times, because the password is a 3-byte password. After that, you try to reset the error counter to 0. If the reset is successful, only then you know that the authentication is successful as well. If trying to reset to 0 is not successful, that means the authentication code is wrong. Now I have authenticated. I'm going to modify, I'm going to edit the memory address from 32 to 47. Just going to keep it all A's. If I hit write, now the write is okay. What has happened behind the scene is there is a command to update individual byte. Now the software has sent this update command 16 times, because each row the software shows 16 bytes. And if you look at the command structure, so here this is the command called 38. This is the command for update memory, followed by the address, followed by the value, and this is the response. You can see a 9D is a success message, followed by 00 is the length of the response. There is no update, doesn't return any response. Now this shows the update command is successful. So likewise, you can read again. If you hit this, it reads the entire 16 bytes. Again, there is no block reading command. You just have to send the byte reading command 16 times. Now seen how the write works. It's a very similar thing. You can write anywhere. The only thing the software doesn't have, and I remember some people have asked for, is it possible to update just a single byte of memory? So we are going to introduce that in the next release. So you can protect. Now as you can see here, the bytes or the columns that are in the red color indicates the protected bytes. You cannot modify them. So the first 2 rows which has a yellow background, so they are the 32 bytes that can be protected from write operation. So keep in mind, any write operation, whether you want to write the user memory or you want to write the production memory, you must do that only after the authentication. So I'm going to lock the byte address 4 and 5. The way you do that is you have to do it one at a time, because this is a learning tool. You have to know that the lock, the way the production, the memory is protected. I'm going to clear this. So I'm going to choose the address as 4 and say write. Now you got some write protection. Okay, please refresh the protection bits. If you look at the command, these commands, this command matches exactly what is in documentation. So it's trying to use the write protection memory command, and the success is 9D, so that means the protection is successfully set. If I read, when you hit this, it refreshes this memory block. So this protection memory, okay, you can see here the color also changed to yellow, red. Now I'm going to write and see what's going to happen. So clear this thing. So the software allows you to, I'm going to set all to zeros. Not sure what's going to happen with my chip data, but this is a brand new tag, I'm not worried. Now if I hit write, it says write data error, not all bytes are written. Now what might have happened here is part of this entire block has been written. If you look at the commands, for some commands, say for example the very first byte was locked, if you look at the response you get 9E. So if you see documentation from 5422, it says 9E indicates error message. It also tells you that what 02 and 00 means. So if it's 9D is a success, 9E is an error. So when the write was made to unprotected memory, we got this 9D00. So because the write was partially done, if I hit this read, you can see that all these locked memory bytes are back to the original value. Now there's something else you need to know about the locking. I'm just going to, which I explained in my earlier videos, but I'm going to set this value to EAA and say write. Now I've set the value of the address 16 to EAA. Now I'm going to lock the memory address 16. Now the way the lock command works is, if you see the documentation of the SLE5542, it says if you look at here, it says the only way you can lock the byte is by the comparing. You have to send the value that is already that matches the one in the memory card. So I explained here. And the good thing about 5422, which I liked, is all the commands that you use, they match what's in the documentation. Now all these say read memory, update memory, read protection. This is the commands. We are sending the commands exactly matching this format. Say read protection memory, this is the command code followed by a address followed by data, and this table tells you when you have to send address and when you have to send the data. Say for example in the read memory, I have to send the code will be, if you convert this to hexadecimal, it will be 30, and you have to send the address, and there is no effect of this byte, but you do have to send a value for byte 3, which probably the software sends 0. And this is one thing I liked in this 5422 way of reading and writing to SLE5542. If you have seen my videos on using with the AC or reader writer, you don't have to go in much in detail. So AC has a higher level functions which does everything under the hood. All these things they are done in the firmware itself. Okay, so I'm going to lock 16. So let's go 16 and say write the protection. If you look at the command structure, it is 3C. If you compare here, so this is write protection memory. If you look at that, the command code is 3 and C followed by the address and the data to compare. Now this is the address and this is the data. So when the data passed in the command, when it matches the one in the memory, only then the protection is done. Otherwise it's the memory is not protected. I'm going to try that. Let's say so here you got 9D0 success. Now I'm going to try to lock probably this one. Sorry, I don't think in the software also do that. So next thing I'm going to show you is how to change the code. So I'm going to try this again. I'm going to remove the tag and put it back and connect and click the ATR and click on a go. And I'm going to authenticate. See, we are going to change the security code. To do that, you have to first authenticate with the known code. I know it's all FFs. I'm going to authenticate. Then I'm going to change, probably now clear this thing. So I'm going to change the code to something, which I remember as well. So I'm going to change the passcode to all A's. If I hit this change security code, it says change, the code is changed. If you look at the commands, this command matches exactly what's in documentation. So you just have to update the security memory. There is a command to update the security memory. If you look at here, now you can update the security memory. Now this is the command that's used here. Now there are two things here. Don't get confused with the update main memory. So the main memory, it's 256 bytes. You have got additional 4 bytes of memory starting address 0, 1, 2, 3, 4. That's address 0 is error counter 1, 2, 3, 4. So we have changed the password, and these are the commands you have to send. So this is the command 3901 is the passcode byte 1 with the value A, and the same command, but we are changing the memory 02, that corresponds to the second passcode, and so on. Now next time I'm going to close this. Try inserting again. Now connect. You have to hit the connect whenever you take this card out. So I'm going to authenticate with the old password. Now the authentication has failed. Probably this message should be in red one. So if you look at what has happened in the background, you can see the last update command used to set the error counter to the default 7 or FF. This has failed. So this is the only way you'll come to know that the password is wrong. So also the error counter has changed from 111 to 6. So I'm going to try A1, A2 and A3. I know even this password is wrong. So keep in mind you got only 3 attempts before the card gets permanently locked. I'm going to authenticate. Again it's error. Now the counter has gone to 4, and don't get confused with this number. 4 doesn't mean you got 4 retries, because it just initially you got 3 attempts, and later on when you use the first attempt the number become 110. This is decimal 6, and when you are wrong second time you'll end up with the number 100, which is the decimal 4. If you try again, I'm going to do that later. Now if I authenticate again, and we are going to lock this tag forever, you cannot undo that. So I'm going to again, here you can see the last command was here. One more thing I would like to bring to your notice is, everywhere if you look at the very first command, the updating the error counter gives you a success, but all these intermediate verify security memory, you will get a error response. Now you just have to ignore them. So I have to spend a couple of hours scratching my head what to do with the error, but you just have to ignore these responses. But you can't ignore this error response. So if this is an error, the password is wrong. So I'm going to put my correct password and authenticate. Look at that, I got my all the 3 attempts back. And if you look at this command structure, the last update is how easy is that, guys, isn't it? So if you're a developer, using these type of commands, probably you'll appreciate the product as well. So I think that's all we have got about SLE5542. We are going to introduce the SLE5528 and 24612 and all those things in the future videos. So please go through the documentation. And finally, the most important and very, very important thing which is going to help the developer is you have to download the sample codes from Omnikey website. This project is going to help you a lot. It's going to teach you now how to integrate with the contact cards using 5422. So thanks for watching. Looking forward to see you in my next video.